So, hi class. We're going to try to make a tree diagram for a probability question. A tree diagram is a type of model that helps us make sense of our choices and help us to figure out the chances of any of them happening. It's just a way for us to keep organized, and it's a pretty good visual. So, to start out, we need to have a question, a problem, and I'm going to give you one. I'm going to say, given, let's say, given you have, let's say 3 colors pieces of paper, 3 colors of paper, okay, and 4 stickers, and I'll let you know what those colors of papers and what the stickers are. I'm going to say stickers, if you have all those fun things. And then I want you to then list the different combinations you can give, let's say give a friend. Alright, so imagine you're cool and you're little and you've got a cute little piece of paper and maybe an invitation or something colorful, and you want to slap a sticker on it and say, here friend, got 3 colors of paper and 4 stickers. Oftentimes, they will give you the information on your choices, either in a list, and I'm going to go ahead and give that to you in a little list form right now. Cool. I don't really need a ruler, I just think it looks prettier. And when we're talking about choices, we often talk about determine what your choices are. We sometimes often refer to it as an event. An event is when you flip a coin. An event is when you roll a dice. An event is choosing the colors of your paper. Or another separate event is choosing your stickers, because stickers and the paper are separate events. Every time you are faced with different options, different choices. So I have three different choices of my paper that I have. That's going to be like a different event. It's a different thing happening. So if I chose a marble, if I flipped heads or tails, those things are all separate and different, and they're separate events. So in this case, the events are we're going to choose some paper, and the second event is we're going to choose the stickers. So I like to just kind of like label them number 1, and that's going to be the paper. And number 2 is going to be the stickers. And I'm going to go ahead and give those to you. So for the colors of paper, I would like to have a white piece of paper, a yellow piece of paper, and an orange piece of paper. Okay. For our stickers, I'd like to have how about a horsey? A horse sticker. How about a dog sticker? A cat sticker? And a monkey sticker. Okay. So now that we have that written down, we need to start our tree diagram, and we're going to put it like right around here. One way I've seen it done, you can sometimes just put like a little dot, and that's kind of where you start your tree branch, and everything branches out. I also like to do this. This is just me. I think it's cute. I think it's nice. It's really obvious then to see where we're starting from. So I write the start. From there, we need to determine how many choices we have in the first event. In the first event, since that's choosing paper, we have 3 choices. We have white, yellow, and orange. Therefore, from our start, we need to branch out with 3 lines to represent our 3 different options from there. So we've got 1, 2, 3. I'm not the best artist, as you guys all know. So at the end of each of them, we write, hey, what are they in words? So the white paper, the yellow paper, and the orange paper. Okay. And along each branch, what we're going to do, is we're going to write what is, in fraction form, what is the probability, right? If you closed your eyes and picked randomly one of your 3 pieces of paper, what is the chance that will be white or yellow or orange? In this case, all of the probabilities are the same. There's only 3 pieces of paper. One's not stickier than another. One's not going to give itself an unfair advantage. You have equal opportunity of choosing white, yellow, or orange. So therefore, there are 3 choices. If you chose white, that would be 1 out of 3. We show that in fraction form as a 1/3 fraction. And if that's true, that's also true for yellow. And that is also true for orange, which is totally awesome. So that's our first event. We've done what we needed to do. We've listed out what we're talking about, what we're looking at. We've also looked at the probability. So now we're done with the first event. We looked at the second event, the stickers. So we've got horse, dog, cat, and monkey. From that, we know we have 4 different options. So from each of the end of these branches, we need to branch out again how many times the second event has options. Okay, so from each of these, we're going to draw out 4 different options. You can be as straight as you want. I prefer straight. I think it looks more tree-like. I've seen some people do some curvy things as well, and honestly, it's fine no matter what you do. I like to have them all sort of lined up, though, on top of each other. It shows separate, hey, here's the first event. The second event will be in a line, column going straight up and down. It just looks more organized that way, especially as we add more and more events, and your paper is going to get a lot more messy. All right, so along here, we're now going to fill in what we know. We know there's going to be a horse, a dog, a cat, and a monkey. Okay, and we're going to go ahead and fill those in so that the whole thing is filled up all the way down. Good. So now that we have those all filled out, I kind of did the fast work for you. We're going to go ahead and do the exact same thing we did back here. We need to list what the probability is of each of these options. And like I said too, this is a special case in that you have an equal chance of getting a horse, a dog, a cat, or a monkey. And since there are 4 choices, and you chose horse for instance, it would be a 1 out of 4 chance. Okay, and so we just go ahead and fill them all in. And yes, I want you to fill them all in. That's required. Sorry, guys. Okay. If you think this is bad, wait till you get to a minute from now. So easy peasy lemon squeezy. Here we go. Okay. Cool. So our tree is in effect, it's done. Okay. We've shown our probabilities for each of our options. We've shown them. It's beautiful. It's wonderful. Now are we done? No, because we need to list out our outcomes. And here's the fun part. Our outcomes are where we list out what could you possibly have gotten. Okay, if you are closing your eyes and you are picking a piece of paper and then you are picking a sticker, what are the possible combinations that you could give to a friend, as we said. So what we're going to do is starting at the start, we're going to go through and list out, just using the words first, we're going to list out what could we possibly get. We could get white combined with a horse, and we show that white, and I put the little circle for like multiplication, and that's going to make sense in just a moment. White and horse. Okay. I also have white and then dog. I have white and cat, and then I have white and monkey. Okay. Then from there, I'm going to start. Okay, we did you. We did you, and you. Now we're going to go back down, and we've exhausted all the white options. We are now going to go to the yellow options and the yellow piece of paper and all of the sticker choices. So we will start out going yellow and horse. Okay. All right, so that was pretty good actually. So we listed out white horse, white dog, all the way down through orange and monkey. So if we follow just with your finger or your pencil, if you followed from the start, you have now gone through every single possible combination that you could make given these options. But are we done? Oh no, we're not. We have one more thing we need to do. And up here under the outcomes, we need to also make a list of what are the fractional probabilities of getting the white horse. Okay. Now we look about the probability of you choosing white from the start, and that is going to be 1/3. Okay, and then we're going to multiply that by the probability of you choosing the horse out of the sticker choices, and that's going to be 1/4. And we're going to go ahead and give ourselves Okay, as you remember, multiplying fractions, multiply straight across numerator times numerator, denominator times denominator. The good news, two things I want to point out. I purposely chose white, yellow, and orange because you can abbreviate them a little bit better. You can write down like W or WH or yellow YE or orange OR. It's a little bit easier when you get into larger trees. Same with horse, dog, cat, and monkey. That was very purposeful. The other thing is, this is a pretty basic probability tree in that most of the options, okay, I'm going to tell you right now, all of the options are exactly the same. You have an equal chance of getting any of these, therefore all of their probability fractions are going to be exactly precisely the same. Is that always going to be the case? Oh, absolutely not. Should I have asked you a question such as, hey, I have 50 pieces of white paper and 1 piece of yellow paper, of course, it is more likely that you're going to have many more times the probability, the chance of you choosing the white paper over the 1 piece of yellow paper. I mean, obviously, that sort of just makes sense. But in this case, since we're starting out small, I just wanted to make it easy on you, and all of these have an equal chance. Is that going to continue? Oh, no. But I just need you to get the basics down before we can move on to like more advanced topics. All right, so we're going to go ahead and fill in white dog, okay, times 1/4, since they're all exactly the same. And before you ask, yes, you do have to fill this in all the way down. Now that I've at least filled it in, what you should notice is, yes, every single one of these is precisely exactly the same when it comes to the probabilities added up, and yes, you should have gotten 1/12 to be the chance of getting any one of these, because of course there are 12 different combinations you could have, and any one of these is 1. One thing that I want you guys to be checking is if you take, okay, do this right, if you take this column right here, which is all of the probabilities, and in this case they're all exactly the same, but they're not always going to be, and you add them up, if you were to add every single one of these up, if you did it correctly, every single time it should equal 12 out of 12, or a whole 1, if you do it correctly, because since probability is some sort of a fraction representing the chance between either 1, which is a certain or a sure thing, it will happen. It's a guarantee. It's a fact. It will happen. And between 0, which is not even a chance, it's impossible. It will never, ever happen. Because it's between those things. Since we have 12 different options, I mean, if you are choosing a piece of paper and you are choosing a sticker, and these are the 12 different options, if you add up all the 12 different options, it should be, yeah, that's 100% of your options, or 1, right? 1 or 100% of your options. They're all exactly the same thing. If you are doing this correctly, it should always be able to, on this column, you should always be able to add it up and get the correct answer. Now, really quickly, why do we do this? Well, because this helps us to be organized, and it helps us to answer questions really quickly and really easily. For instance, if someone's to ask you, ooh, I really love horse stickers. Horse stickers are amazing. I really want one. If I was to close my eyes and randomly pick a sticker in a piece of paper, what are going to be the chances that I get a horse sticker? I just want a horse sticker. Okay. Well, to find that, you go and find all the ones that have a horse sticker, such as this one, and you find its probability, which is 1/12. You find this other one, which is also 1/12, and you find this last one over here, which is 1/12. And when you add all 3 of them up, you get 3/12. Okay, so you have a 3 in 12 chance of getting a horse sticker, which is pretty good odds. And then what if I'd say, hey, you know what? My favorite color paper is orange. I love orange. Love it. What are the chances of my closing my eyes and picking anything? I don't even care about the stickers. I just want the orange paper. What are the chances of me getting orange paper? Well, finding all the ones with the orange paper. Okay, 1, 2, 3, 4, and they're all 1/12. So there are 4/12. Okay, which is, if you put it down into lowest terms, which you should be doing, you will notice 4/12 is the same as 1/3. Which, if we go back over here and we notice, okay, a third of our choices we know are going to be the orange paper. So you kind of already knew that from the start. Just to be tricky and a little bit evil, what if I say, ooh, I love orange paper, but I also love dog stickers. what are the chances that I get either and or either my orange paper or my dog sticker? Okay, and this one's a little tricky because people want to say, oh, there's the 4 orange papers and there's a dog, and there's a dog, so 3 plus 4 is 7, and that's not exactly true. Okay, if I'm going to be satisfied, if I'm going to be happy with, orange or dog, then yes, this dog does count because it's on the white paper, that's fine. And this dog does count because it's on the yellow paper. But when we get to this orange dog, we can only count it once because that's one combination. It's not 2 separate combinations. Okay, so it's actually 4, and then 5 and 6. So your chances, if you like orange and dog stickers, I mean, you have a 50-50 chance, 6 out of 12, of getting something that you like, which is a really positive thing. Okay, so that's the basics of a really easy tree model, a probability tree model.